Good afternoon. I'm John Osmeña from Group 1, and I'm here to present and demonstrate Lab 2 or Experiment 2. I am given the task of question 3 and question 5. Question 3 has this large truth table that has A to G outputs, and question 5 has the both implements tasks you to implement uh, their givens to a logism circuit. For 5, we need to apply this K map, as you can see here, to a logism circuit. So I have made, I have implemented them. So as you can see, so let's just restart this. And I have also made a K map for both of them. So this is a K map for the question 3 for outputs A, B, C, D, E, F, and G. They all have quite messy colorings because Excel does not support the blending of colors, and or I don't know how to do that in Excel. So basically, this is what they may look like, and their sum of products and their min terms. So here you can see, and the D, E, and F, and for G. So implementing them into K-map, you see here, this is what would they look like. So you can implement this using only one not IC, but I have utilized giving each output their own not ICs to make the circuit easier to read, less confusing, and much more cleaner. And I've also avoided the not utilize the free spaces on the other ICs like the AND IC or the or IC, so that there are no interlocking wires, and there's no you can see it clearly and it's not confusing. So as you see here at the A at all zeros, so let's go back to uh, the table. So at all zeros, the output should be all ones except for the output G. They're all ones except for the G. For D being a high value, the output should be 0, 1, 1, and 4 zeros. That's correct. So for the output 11, 0, 0, 0, 11, the output should be 4 ones and 3 zeros, 4 ones and 3 zeros. And for the 0, 0, 10 output is 11, 0, 11, and 2 zeros. So moving to the 0, 1, 0, 1, 0, 0, the output should be 0, 1, 1, 0, 0, 1, 1. And for 0, 1, 0, 1, the output should be 1. Output should be what happened here. It was fine, fine. 0, 1, 0, 1. This should be 1. What happened? Sorry for the error. Let's double check it. So sorry about that. I have placed the wrong wire over here. I have placed here at this pin C, this wire instead of the input. So that's why it yielded the wrong one. So now it's correct. Looking at the truth table again for 0101, it's 10110111, and for 0, then all three ones input is 1110 and zeros, and for the 0110, 1 0 1 1 and all ones. Okay, correct. And for output of 1 and all zeros, that should be all ones. They're all ones, and the output of 1001 is 111 for the output E and 1 1. So it's correct now. So that's for question 3. And for question 2, let me just see. This is my pre-made question 2. And why is there an error? Let me just fix it again. Let me restart the revision. So I just refreshed because there was a bug. It was showing that the wires here were errors and the out pin showing an error. So moving to the came up for number 5 here. Show you the Excel. So basically here, this came up, it shows the zeros, but it says here you should use the sum of products. So all the zeros are considered zeros and not uh, prime true A's, or not they're considered as prime A's or complementary A's or stuff like that. So here the blank spaces are rendered as 1, as you can see here. In this K-map that I have made for the question 5, these blank spaces are considered as ones. So we have yielded sum of products of W ANDed with Z, or with X prime ANDed with Z, or with W prime ANDed with X ANDed with Z prime, or with W uh, ANDed with X prime. So that's put here, and this is how it looks when it's implemented to uh, as a logism circuit. So if we show this, this should be for, I don't have a quick table for it. So for 001, 11, 0010, and for 0100, as you can see here, let's demonstrate 00 is 0. Uh, 0101 is also a 0, 01, 00110, 0010, so it's a 0, 0111 is also 0, 1100 is also 0, and 1110 is also 0. So it's basically correct for the correct setup for the key map and the circuit. So that's all for questions 3 and 5. And again, for group 1 lab 2. So thank you for watching and listening.